Hello from Intellipaat. The topic for today is how Big Data Hadoop works and the HDFS architecture, which is going to be our focus today. Right? So, we're going to understand how HDFS works with respect to big data. First of all, let us go through the agenda that we have for today. Firstly, we're going to have a little bit of introduction to big data for those of you who are coming into this particular domain newly, right? We'll go through all of the basic terminologies of what constitutes big data, right? We're going to understand all of that. We're going to understand the problems associated with big data. Then we're going to head on over to HDFS, which is the Hadoop Distributed File System. And we're going to understand how that is a solution for big data. We're going to understand the HDFS architecture and working. The topic is how big data works. So obviously we'll go through the working of how you store big data and how that big data can be accessed or written onto the HDFS. We're going to understand that. And then finally, I'm going to show you with a live demonstration as to how you upload files on a big data server on a HDFS server. So that is going to be a small demonstration as well included in this particular webinar, right? Without any further ado, let us begin. So, the first thing that we are going to go through is introduction to big data. Now, it is important, it is almost imperative that you need to understand what data is as a fundamental concept before you understand what big data is. Data is not just simply something that is available on your file system. You need to understand the specifics of it as well. So, data is the individual unit of information that is defined as figures or facts and is stored for later processing. Now, this could be image, this could be text files, this could be music files, this could be other files as well. There are a lot of file formats. You must have seen it on your own file system as well. Fundamentally, these data sets or data is classified into three categories. The first is structured. Now, this is the most familiar sort of data for people in the data analytics slash data science slash database management domains. Structured data is essentially data which is present in tables, SQL tables to be more precise. So these data sets essentially have column names associated to them and they have rows, right? There can be a primary key, there may not be a primary key, but it is essentially a data which is absolutely well structured. It can be accessed, mathematical operations can be performed on it. You can calculate possibilities, probabilities. In fact, in a lot of supervised machine learning algorithms, this is the data that you need to have for those algorithms to run, right? The second sort of data that we have is a mismatch of completely random information and structure, right? In this particular data set, what you have is not SQL tables. You have files which contain a certain amount of text in them. So this text could be in a particular format. Now that format is custom and that could vary essentially, but it does have a structure to it. For instance, there is CSV files. CSV is short for comma separated values. So whenever you are creating a text file and you're separating all of the data records with a comma, right? Although it doesn't seem to be of structure, it could still be a text file, but it does have structure when you delimit all of the data values with a comma and put it into an algorithm. Some structure can be obtained from it, and this particular data set can be converted into a structured data set, which means it could be converted into an SQL table. So that is what semi-structured data is. So data with a certain amount of structure, but not exactly an SQL table. And lastly is the data that is unstructured data, right? So this data does not have an order to it. So what will happen is you put this data into an algorithm that can derive some order out of it if any order is possible at all. So this could be JPG, MP3, MP4, all of those sorts of data sets are structured data sets, unstructured data sets, essentially. So now that we know what data is, what if we boost that data? What if we amplify the amount of data, the speed of data, right? The amount of data that you currently have. So when you significantly increase that amount of data, it becomes big data. But it's not that simple of an explanation. There are some criterias that have to be satisfied for data to be termed as big data. So these are called the five V's of big data. If you say the first V would be the velocity. Now, velocity means speed, and that means that the data that is coming into your server or your storage location should come at a very rapid rate. So that means that it could be around 1 terabyte per hour, right, or 1 terabyte per minute. So that those are the kinds of capacities that we're looking at in the minimum. So this could go up to petabytes as well. Then we have volume. So volume means obviously size. So that means the data that is coming in or is being stored, even if it's not coming as fast as we want it to, it still should have volume, which means size. So anywhere above 1 terabyte to petabytes is considered good enough for data to be termed as big data. And then we have variety. So variety means that data should not be coming from a homogeneous source, which means that the data should be of multiple file formats. The data should not be coming from one database, which means, say, for example, Amazon must have a customer data set and must have a sales data set, essentially. So when you're compiling that all together, the data is coming from two different databases, which is the customer database and the sales database. So when you combine both of those, you get big data. Then you have veracity, which means that the data that you're getting will not be perfect. So in any real case scenario where you have petabytes of data of actual things in the world, there is a very high possibility that the data has noise in it, that the data is inaccurate, the data must have missing values in it, or the data must have incorrect values in it. So that is veracity. Practical application, you will not get perfect data. So veracity is also a criteria that needs to be satisfied for data to be termed as big data. Then you have value. So whatever data that you are extracting or getting should not be random gibberish, right? So it cannot be of no sense at all. Say, for instance, you're analyzing academic data, and in that case, the roll number of a particular academic student may not matter as much as their grades, as much as their academic performance, right? So even if you take the roll number column of that student, you cannot actually create any sort of data analytics or data science model out of it, right? So the data of the roll number is not of value. So the data should always be of value as well. So I hope that clarifies what the five B's of big data are to you. So heading on over to the problems that we face when we are dealt with big data in general. So big data is not something of a small size. That much has been established, right? So what that means is we need appropriate storage for that big data to be stored. So right off the bat, we have the problem of storage. You cannot store big data on your computer. You hardly have 1 terabyte of hard drive space in the computers that you get today. Let alone storing petabytes of data on a laptop. Forget about it. You can't do that. So it's very hard to store. So there needs to be a solution for that. And secondly, even if you're able to store that much data with the one processor that you have in your laptop, it is very hard to process as well. So say if you run an algorithm on that data and you have a 4 core processor, you can forget about analyzing petabytes of data without passing in an year or months, for to say the least, to process that data, right? You need to have a proper architecture to deal with this problem. So these are the two major problems that are there with big data. And with Hadoop, essentially, when Hadoop was launched and Hadoop came up with the HDFS, the big data storage problem was solved. So how was it solved? We'll get into that in a bit. Basically, we need to understand what HDFS is. HDFS is an abbreviation for the Hadoop Distributed File System, which means HDFS is a file system designed for storing very large files with streaming data access patterns running on clusters of commodity hardware. So very tricky words that were just used. We'll go through this point by point. This means that Hadoop, first of all, HDFS, is an implement to solve the big data crisis by combining a lot of computers together, right? So commodity hardware means something that is not expensive, something that comes in your use in day-to-day life, but it still solves the problem of big data. You might be thinking, okay, how is my laptop with such low requirements useful for storing big data? Your laptop alone is not the appropriate answer to store big data, but your laptop combined with a lot of other laptops like that, right, and together in a network is a solution for storing big data. So imagine if you dedicate a particular percentage of your hard drive to storing big data while you're working in an organization. You all have workstations. You dedicate a particular percentage of your hard drive to storing the big data in your organization. So all of those combined together on a local area network, for instance, with almost negligible latency because you are all so close. You can store big data in that environment by installing Hadoop onto your system and implementing HDFS. So that is how you solve the problem of storing big data. So one of the things that it does, it stores very large files because you're dividing the file into multiple sections and storing it across all of the nodes, right? So that is the problem that you solve with that. Secondly, there's streaming data access. So each analysis of the data set involves a large portion of the data set, right? So the time to read the whole data set is more important than the latency in reading the first record, essentially. So this essentially means that whenever somebody is trying to access this big data cluster from a remote location, even if he's far off, the latency does not exactly matter because at the end of the day, even if you have a 200 millisecond of latency, which means the time it takes for the client to connect to the HDFS server, you still can give instructions and the data would be processed in the given time, right? The data would be processed for as long as it needs to be processed, and the time is significantly reduced when you're using HDFS in your processing architecture, right? So this is the advantage of HDFS. And thirdly, you have commodity hardware, which means cheap hardware, which means you don't have to buy dedicated servers to store your big data. You can use normal commodity hardware, which are cheap to come by. You can connect them all together and create your own big data cluster. Let us go to the architecture and the working of the HDFS. Firstly, let us understand the architecture. The architecture consists of primarily two elements. The two elements are the name node and the data node, right? So the name node is the node that contains all of the metadata, which means the data of that data, the introduction, the starting point, and the end point of the data. So essentially, what will happen is the client will write a file and the client will read a file, right? So whenever the client writes a file onto the HDFS, the name node stores on which particular data node the starting part of that file is, and on which particular data node the end part of that file is, and on which particular data node the middle part of that file is. So there are a lot of nodes that come under the data node, the name node, and the name node controls and coordinates all of these data nodes together. So the name node could be a commodity hardware that is not that high on specs essentially, which means that it does not have a lot of storage space, it does not have a good processor, but a name node can simply act as a controller of the data nodes which are significantly or comparatively higher in specifications, right? So let us understand how the process works. So if you're trying to write a file onto the HDFS, the client will request to create a file, right? And that information will be sent to the name node, and then name node basically is contacted once the upload has accumulated to the point where a block size has been reached. So the block size is essentially the threshold set in the HDFS, which means that if the file is above this particular size, you will divide it into parts, right? So you'll divide it into parts of the block size. Basically, take the entire file size and divide it by the block size that is set in your HDFS, and it will be the file will be divided into those many blocks, right? So the name node responds with a list of data nodes that are available and free to store this file. The data node receives data from the HDFS clients and it writes to the local space that they have. The data nodes write the file parts, the blocks to the space that they have. Right? The data node forwards the file to the second data node for replication and then to a third. So this is a very essential part and one of the most interesting factors of the HDFS. So say you have file blocks, right? You have divided your files into blocks. The other thing that HDFS solves, say one of these data node fails, right? So what happens to that first block of your file? Say if your file has been divided into three blocks and one of the data nodes fail, do you lose the first block and you only have two-thirds of the file? No. What the HDFS does for you is it replicates all of these files across all of these data nodes, right? So it's replicated as well. So when one of the data node fails, you still have the backup of that file and you can still read that file because you still have it intact even if the one data node fails, right? So that is one of the key factors, data replication. It is replicated, and then the name node commits the file creation into a persistent store. It receives heartbeat and block reports. So the name node is constantly checking which data nodes are healthy and which are not. So if one is unhealthy, the data node will not try to access the files from there. If somebody tries to read it, it will access the file from some other data node, and it will not use that data node for file storage as well. And the client gets the data node list from the data node. It reads from the replica closest to the render. So the other thing that happens is you also want to reduce the latency at which you read the file. So wherever the client is closest, right, whichever data node the client is closest to, he'll read that particular block of that file from that data node itself to minimize any delay in reading that file. So let us understand all of this with a demo. So let us get to the hands-on section where I'll show you how you store a file in the HDFS. So currently I have my CentOS 6.3 virtual machine open. Now this has Hadoop installed in it, and this is the virtual machine that you would get if you apply for any of the courses at Intellipaat. So firstly, I'll open up my home directory. Right, so I have some files over here. So say if I wanted to import this particular file, which is the weatherhistory.csv file, to my HDFS, because it was a big file, right? It might not be a big file right now, but I'll just show you the procedure of how we would actually put it into the HDFS and how simple all of it is, right? So as I told you earlier on, HDFS is a combination of nodes combined. All of them are combined together, and they basically are part of a network, right? So whenever you try to upload a file on the HDFS, it automatically gets divided into blocks of the designated block size of your HDFS, and then it is spread across all of the nodes in that particular big data or Hadoop cluster, right? So when that happens, uh, it basically is split up in various sections, but when you try to access it, you'll see it as one file and one file only. So I'll show you how that works. So for now, let us open a terminal. First thing we have to do is open up a terminal. So currently I have a terminal open. I'll just expand the text so you guys can see as well. That is enough, right? So firstly, I'll just bring that window up again and I'll type in the commands. So first thing that we need to do is we need to create a directory to store that file in. So it is simple. Similar to how you would do it in your normal file directory, you would do it in the HDFS as well. So you will type in Hadoop fs hyphen and then mkdir. So mkdir is short for make directory in Linux. When you write that, you can simply type in something like new folder. Right. So imagine that we are creating a folder within our HDFS, our Hadoop distributed file system. We do that. So our folder has now been created. Right. So the next thing we would do is we will look at the file name that we want to transfer. So in this case, it's weather with with a small w and a capital H history.csv. So we want to transfer that into our HDFS. It's simple. Since in Linux, your present working directory would always be your home directory. So we will type in Hadoop fs and then a Hadoop command, which is put. So what put does is the first argument in put is the file directory on your local file system, and the second argument is the file directory on the Hadoop file system. I'll type in weather history.csv, which is the file we want to copy. And the second would be the new folder that we just created. So once I enter that and I bring this window over here and I press enter. Takes some time, but it transfers the file into that particular folder. So if we can simply type in Hadoop fs-ls, which is another Linux command, but you can use it in the HDFS as well, and then type in the new folder name that we just created. Press enter, and we can see that in the new folder there is a weather history.csv. That is how Hadoop works in storage, essentially. And that brings us to the end of our little demonstration here today, guys. This was just to give you an idea of how the HDFS works and how big data storage works, right? So, if you're interested in this particular course, if you're interested in big data in general, we have courses for big data, very specific to your needs. It may be you can contact our course advisors. They'll assist you in finding the perfect course for your particular needs, for your particular job requirements, right? So these are the contact details presented on your screen here today. You can contact the sales team using sales@intellipaat.com. You can chat with our course advisors so that they can guide you. They are available 24/7. And be sure that you sign up for our webinars because we discuss technologies like these almost every day. So be sure you keep up with us by signing up with our webinar and attending our webinars and asking your doubts first and foremost from our course advisors, from our trainers. With regards to these technologies, you can ask your doubts one on one. When you're attending our webinars, you can ask the questions, and the trainers and course advisors will answer your doubts. So, the webinar link registration is in the YouTube chat box. You may sign up for it for the next webinar, whatever we have. So, that is about it from Intellipaat. Thank you for attending this particular session, and goodbye.